Alright then, so now we know a lot of the basic built-in types and how to use those types with functions as well. Now I want to talk about a special type in TypeScript called the any type. And the any type basically means that whatever variable has that type can take on any type in the future, and its type can change. So for example, I can make a variable called age and set the type of this variable to be any. And that means in the future this variable can be any value of any type. So I could say down here age is equal to 30, and that would be absolutely fine. And then later, if I wanted to, I could also say that age is now equal to false instead, a boolean, which is also fine because we're using that any type to say this variable can always have any type it wants. So you can think of the any type as like a cheat code, I guess, as like almost a way to revert back to JavaScript, where a variable can take on any type of value interchangeably in the future. And if that's the case, then using the any type is almost like ripping the beating heart out of TypeScript itself. And if you're using it often, then you're not really going to see the benefits of using TypeScript in your code because you're not going to get good error feedback when something is wrong. So, for example, I have this age variable. If it should be a number, then we should declare it as number. If we declare it as any type, then TypeScript doesn't really know that this should be a number. So we're not going to get good code hints or code completion from VS Code because TypeScript has no idea what the exact type is that you're using. And you'll most likely get more bugs at runtime. So although at first the anytime it might seem like a cheap way to apply a little bit of flexibility in your code, it comes at a big cost. Anyway, I've got that little run out of the way now, so let's look at some more examples of using this any type. So another way that a variable gets the type of any is if we declare a variable like title, for example, but then we don't give it a value and we don't say what type it's going to be. And then automatically it's going to give this a type of any. Okay. So now I could come down here and say that title was equal to a number like 25, and that would be fine. I could also say that title would be equal to an object. And we're going to have a property called hello, really random. And then the value is world. So this works as well because title can have any type. Alright. Alright, so we can also use the any type inside arrays. So I could say let things equal to some kind of array, and then I'm going to type this. So colon after things, and then any, and then square brackets. So before we did something like this, number or string, and then square brackets, and that meant that only numbers or strings, whatever type we declared, can go in those square brackets. When we say any, it means that any type can go in this array. So I could say hello right here. I could also say true. I could also add a number, so 30. I could add null if I wanted to. Any type can go inside this array. Alright, then also if I wanted to push something else onto the array, I would say things.push. And then it could be any value. I could push on an object if I wanted to with an ID property of 1, 2, 3. That would be fine because there can be any type inside this array. Alright. So let's also have a look at functions using the any type as well. So I'm going to create a new function. We'll say function. It's going to be called add together. And it's going to take in a value, which could be of type any. So we could pass in a boolean, we could pass in number, we could pass in a string, whatever you want, because the value is of any type. It's also going to return a type of any as well. And then inside here, all we're going to do is return value plus value, like so. Alright, so I could pass in a string right here. I could say const result1 is equal to add together, and then pass in a string which is hello. Now, when we add two strings together, it's going to concatenate them, so it would be hello, hello, the result. I could do const result2 and set that equal to add together, and then pass in a number 3. When we add two numbers, it's going to be 6, the result. So the type of this would be a string, the type of this would be a number. However, because we used any right here, and we're returning the any type, TypeScript doesn't know about what types we're passing in or what types should be returned. So if I hover over result1, you can see, well, it's just going to be any. Result2 is going to be any as well. So basically, it's taken away the power of TypeScript because it's not going to be able to give us any good error feedback if we try to do something with this value later on that we shouldn't be doing. Alright? So there is one useful case for any, in my opinion. Maybe there's some edge cases as well, but one useful case would be when you're migrating a project from JavaScript to TypeScript, because if you're starting to add types to things, then that can all of a sudden give you loads of errors in your code, and it can be quite awkward to go through all of them one at a time and try and correct everything adding types. So to begin with, you could add any types for your data. That's not going to cause any errors because essentially it's behaving the same way as JavaScript them. And then gradually you could add specific types to your values. So that is one use case of using any, but generally speaking, I try to steer clear because it does rip out all the benefits from TypeScript. Okay, so now let's move on to another type of data we can use in TypeScript, and that is a tuple. Now, a tuple in TypeScript is a little bit like an array, but whereas an array typically is a collection of values of a single type in no specific order, tuples allow what is essentially an array of values of different types in a very specific order. So the easiest way to understand this is, I think, by doing an example. So let's do that by making a new variable called person. And then I'm going to set the type of this variable. So we need a colon first of all. And then for the type, we'll use square brackets. And then inside those square brackets this time, we're going to say string, then a comma, then number, and then a comma, and then Boolean. And this means that the person value is a tuple, which is like an array, where the types of values inside are in this very specific order now. So I could set this now equal to a value, which is square brackets, again like an array. And now inside here, the first value has to be a string, and the second value has to be a number, and the third one has to be a Boolean. And if we were to try and change the value of one of these things inside the tuple to a different type, for example, if we try and set the first value to be a Boolean, then we're going to get an error because that first value must be a string, because that's what was specified over here when we typed it. But we cannot change the value of the string. That's not a problem. It can be whatever string we want. It's the type order within a tuple that really matters. So again, very much like an array, where the types inside it are in a specific order. Now, personally, most of the time when I'm working with TypeScript, I won't reach for tuples too often because I always feel like there's a different approach which works better for me. But there are some cases where they're a good option. So now let me just go through a few examples of where we might use one. So then down here, I'm going to create a new variable called HSLA. And this is going to be a tuple, so I'm going to type it as such. And the first value will be a number, then a string, and then a number. So this is a common format for colors: hue, saturation, luminance, and then this is an alpha channel, so it dictates the opacity. So they have a very unique structure, these kind of color codes. The first one is a number. Then it's a string, which could be like a percentage, like 50% or 100% or 70 or whatever. Then another percentage, which is a string, and then a number from 0 to what. So that would take up this very unique structure. Therefore, I'm using a tuple. So I could say HSLA is now equal to, and the first one is going to be a number, 200. Then a percentage as a string, so 100%. That's why it's a string, because percent is not a number right here. We have to use a string. And then after that, it will be 100% again. In fact, no, we'll do something different. We'll say 50%. And then after that, 1, which is the alpha channel, the opacity. Alright, so that's one example. Another example would be coordinates. So I could say let x, y be a tuple where they're both numbers, so number, and then number. And then I could say that x, y is equal to, then also random numbers like 94.7. And then the next one could be 20.1, like so. We could also use them inside functions. So I could say function use coords, and that is going to return a type, which is a tuple when we have a number and a number, like so. And inside here, we could do some logic to get some coordinates of the user or something. And then down here, we could register them. So I could say the const latitude is equal to 100. These are random numbers. And then the const longitude is equal to 50. And then I could return that tuple. So it would be this structure right here that we're returning. So a number and then a number. So latitude, then longitude, I could return lat long, like so. And then I could invoke that function. I could say const and I would destructure by saying lat, and long would be equal to use quotes, like so. And it knows that this is going to be a number, and that this is going to be a number, because that's what we specify right here, a tuple with number, and then number. So that's just a few examples of where we could use these tuples. Now, one of the main reasons I often used different data structures instead of tuples in the past was because unless you know what the different values inside a tuple represent, it can be quite hard to figure out what they're meant to be. For example, if I didn't tell you this was X and Y coordinates ahead of time, it probably wouldn't know what they are. They're just two random numbers, right? But a couple of years ago, with the release of TypeScript version 4, came with it the ability to have named tuples, whereby when we define a tuple type, we can add names to each value within the tuple. So let's have a little look at how we can do that. So let's create a new variable called user, and I want this to be a tuple, so I will do a colon to type it. And then inside square brackets, we're going to say the first element will be a string in this tuple, the second one a number. Now, without knowing what this string and what this number represents, it's pretty meaningless, right? So I would like to say what this string is for and what this number is for using a named tuple. And the way we do that is by saying that this is a name property over here. It's not really a property like an object. We're just identifying it. And this second one over here will represent the age, this number, okay? And now, if I come down here and say that user is equal to something, if I hover over user first of all, I'm going to see that the first one represents a name and the second one represents an age. So we get like kind of feedback, so I know what I'm going to put into this tuple now. So I'm going to say peach. And then for the second one, I will say 25. By the way, if I try to put something in that's not a number like true, then we're obviously going to get an error because it doesn't conform to this tuple type right here where it must be a number. So let's go back to 25 like so. And now also watch this. If I say console.log and then user, and then I'm just going to get the first index. So it behaves like an array in that respect. We can just get values from a tuple using the index. If I do that, I'm going to hover over this again. If you hover over the 0, it says what the property is. It's a name, okay, and it's a string. So that's named tuples. It just adds a bit more context to tuples, if you like, and it really helps when you're using them, I suppose. Alright, cool. So in the next lesson now, we're going to look at interfaces. Okay then, my friends, so now I want to move on to something much more fun and interesting, which kind of opens up a way to define our own custom types, and that is interfaces. So, in a nutshell, interfaces are a way to define a certain structure that other data structures can adhere to, whether they be classes, object literals, or even other interfaces. Now, that might sound like gobbledygook complete nonsense, so let's just dive right in and do a few examples. So, let's imagine we have an application that lists a bunch of blog authors on a page, and each author would be represented by, an object. Now, it might be that you have several author objects and they all need to adhere to a specific object structure. For example, they might all need a name property, which is a string, and they might all need an avatar property, which could also be a string. It could be a URL to a picture or something. Now, we can impose that kind of structure on objects by making an interface for an author, which describes what properties and what type of values those properties should be on an author object. Now, the way we do that is by typing interface first of all, and then the name of the interface, which I'm going to call author, with a capital A, and this capitalization is convention for interfaces. It's called Pascal case, where each word starts with a capital letter. Alright, so now we're going to open up our curly braces and define the structure for any object which implements this author interface. So we're going to have a name property, which is a string, and we'll also have an avatar property, which is also a string. Cool. So now we have this interface, and we can assign it as a type to variables, much like we assign strings, booleans, numbers, and arrays as types. So let's create a new constant, and I'm going to call this constant author1, and I'm going to give this a type of author, which is the interface, which means that this now has to equal an object with these properties. So I could put in here, we have a name property, and that's a string, so we'll say this one is Mario, And then also we need an avatar property, and that's also a string. And I will say that's /image/Mario.png, right? And now there's no errors. If we had a third property, like age or something, and that was a number, then we're going to get an error on this to say, look, this is not in the interface. So let's take that off. And now we have this author object, which is of type author. It adheres to this author interface. Alright, so let's make a new interface now for something else, and this is going to be for a post, so like a blog post. And a post might have a title, which is a string. It might also have a body, which is a string. It might have some tags, and those tags could be our type string array. And then we could have a created at property, and that could be a date. And then we could have an author, and that could be of type author. So we can type properties like this inside other interfaces as our own custom interface type. So now if we created a new post, I could say constant new post is equal to something or other. And what I will do is type this as a post. So now down here, we need to add in all the properties. We will say the title is going to be something like my first post. And then we'll do a body, which is something interesting. And then after that, we will do tags. And the tags is going to be a string array. So we'll say, I don't know, gaming, tech, maybe. And then after that, we will have a created at property. Now this is a date type, which means it must be some kind of date object. So we'll just say new date for this. And then below that, we'll say the author. Now the author needs to be of author type, and we have a constant right here called author1, which is of author type. So we could use that. We could say author1, and it allows us to do that because this is of type author. If we added on any old random object right here, then it's not going to allow us to do that. It has to adhere to this interface. We could write out here, so we could add a name and an avatar, and that would be fine. But I'm just going to use author1 instead. Awesome. Alright, so that's how we can create these interfaces, which kind of dictate how an object looks in terms of the properties it has and the values of those properties, or rather the types of those properties. So now let's have a look at using these interfaces as argument types. So what I'm going to do now is create a new function down here, and this function will be called createPost. And it's going to take in as an argument something called post, and the type of this will be post, as defined right here by this interface. So whatever we pass in must be an object, like this kind of thing right here. Okay, so it's going to return nothing, so we'll say void right here. And then inside, I'm just going to log something to the console. Typically, you might do something like, say it's for database, whatever. I'm going to say console.log, and we'll do a template string, which will say created post. And then we'll output the post title. So it'll assign curly braces and then post. And then if we say dot, it's going to know all of the different properties on this post because we said the type of this is a post, and it knows that a post has these properties. So it gives us good code completion right here. So we can say post and then look for the title, and we'll output that. We'll also say who it's by. So we'll say by, and then $sign curly braces, post, then dot, and then the author. Now the author itself is an object, and we have an interface for that. And we said the type of this author property is author as defined by this interface. So if we press dot again over here, it's going to know those two properties because it knows it's of author type. So we can use the name right here to output the author name. Awesome. So let's try invoking this function. I'm going to say down here, create post, and invoke it. And notice we get an error because it expects an argument. So let's pass an argument in, which is an object. Now all I'm going to do is pass in a title property, which is a new post title. Now we still get an error. And that's because this must be of a type post, not just any object. So it has to have all of the properties as defined here. So instead of that, let's just try passing in this new post, which we know has all those. So new post like so, and now we don't get those errors. Awesome. So what I'm going to do is save this and then open up the terminal to see this logged to the console to make sure it's worked. And we can see created post, my first post, which is the title by Mario, the author. Awesome. Alright, so finally, let's have a look at how we can use these interfaces with arrays. So let me first create a new variable, and I'm going to call this posts, and I'm going to type this to something. So much like we can have arrays that add types so they can only have certain types of data like strings by saying something like string array, we can also do the same with our own custom types using interfaces. So we have this post interface, and I could say I want to have an array where only post objects can go inside that array. So I could type that as post array like so. And to begin with, I could set it equal to an empty array. But then if I wanted to add items to this array, I could only add post objects. So let me say posts.push. And then if I try to add any old object or even just a string, for example, that says hello, I'm not going to be allowed to do that because that's not a post object, obviously. If I try to add an object with some of the properties like title, and maybe also give this, I don't know, what we've got a body. Hello again. You can see we get an error because this is not a post object, we just have a couple of the properties. However, if I add in the new post, which is this thing right here, this object that we created that is of type post, then it's going to let me do that. So new post like so, and that works. And by the way, we don't have to say this is of type post right here for that to work. So if I get rid of this like so, and just say that new post is equal to this object, then these things where we pass new post into the function right here, that works. And when we pass new post into this push method to add it to this post array, that works as well. So this doesn't have to be explicitly typed as a post object, and also it's not going to infer the type right here because this in TypeScript's eyes, it's just an object, right? It just so happens that it conforms to this structure. So when TypeScript is doing checks right here, it basically says, okay, does this thing right here that we pass in, this argument, does it conform to this interface right here? Does it have all the same properties? And are those property types the required types? And in this case, yes, they are. But if I changed one of the types right here, like if I changed this to a number, like 3, for example, then this is not going to work. And this is not going to work, right? Because it recognizes now that these properties and types of these properties are not the same as defined right here. So let me just hover over this, and you can see that this is not inferring it as a post, right? That's important. It's not inferring it as a post. We have to explicitly say when we're using an interface that this is a post if we want to give it that definite type. Okay. But nevertheless, if we take this off, this object still adheres to the structure. And so we're allowed to pass it into functions where we declare that it must be of type post, or that we have an array of type post inside the array, and we can add them to it. Okay, so there we go, my friends. That is the basics of interfaces. They're a really powerful feature that allows us to kind of define these custom types of data. Now, later on in the course, we're going to go into much more detail about interfaces, how they can be extended, and work alongside other data structures like classes. And that's where they're really going to shine. This was very much scratching the surface of what they can do for us, an introduction to interfaces.